reflection, we're going to talk about reflecting things on the coordinate plane. You did this in 6th grade, so let's just look at what 6th grade looked like. I know, kind of a mess, but you've got it together now in 8th grade. In 6th grade, we just took a point and we reflected it across the x or the y-axis. So in this case, I've got this point here, which is 1, 2, 3, -3 on the x, and 1, 2, 3, +3 on the y. If we reflected that across the y-axis, 1, 2, 3, 1, 2, 3, we'd have this spot right here, which is +3, +3. Right? And what we talked about in the last lesson is that this would be the pre-image and that would be the image. So this would be the point prime. We could also reflect it across the x. So this is 3 above the x, so we would go 3 below the x here to say -3, -3. So this is a reflection of this point across the y-axis. Now that's all we're going to do differently now is we're going to do it with a shape, with a series of points that are in the form of a shape. The idea of this, though, is a twist is that we can have a line of reflection, and that line of reflection, what we're used to seeing is a line of reflection of being like the x-axis. So we can reflect something across the x that look like this from here to here. Or we can reflect something across the y-axis, which is from here to here. Now, what's also true, though, is that we could reflect something across a different line. So let's say that that line was, really any line, frankly. Let's say that that line was y = 1. So if we were to reflect this point across y = 1, y = 1, of course, is that horizontal line that sits right here. The reflection of -3, 3 across y = 1 would be here. 2 above y = 1, 2 below y = 1, so then that is then -3, 1. So reflected across a line of reflection that isn't an axis, but is just any line that could be created. Now, we're going to focus mostly on the axes, so don't worry about this too much, but you should be capable of this. This is not a stretch. Okay, we've got a shape here, we've got a triangle here on our coordinate plane. I want to show you something first, though, before we start this. So that idea of reflection is something that looks like this. So if I have a rectangle here, A, B, C, D, if I was going to reflect that across the x, so what I would have is the mirror of that shape down here. And what I want you to notice is that points D prime and C prime are the points in A, B, C, D that are closest to the x-axis, just like C and D are closest to the x-axis. Like in translations, though, we just moved it, so the orientation of all the points stays the same. In reflections, when we reflect something across it, we end up with kind of a change in the rotation or the orientation of the shape. B prime and D prime are close to the y-axis here. If we bring that back to the pre-image, B prime and D prime are also close to the y-axis as opposed to A and C. All right, so looking at this, we're going to do this triangle here, and we're going to go across the x-axis. So there's our x-axis, so we're going to take this, and we're going to do the mirror image of it down here. If you notice my hand turning over, that's exactly what's going to happen when we do the shape. So all I'm going to do is look at it in relative to the x-axis. So here I'm 2 points above the x-axis. My x is not going to change, but I'm going to put my point in here. This will be A prime. Here's B, which is 1, 2, 3 above. 1, 2, 3. So I go 3 below. There's B prime. C is 1 above the x, which means I'm going to put C prime 1 below x on the same x. And then let's connect our lines. So let me get my straight edge here. So I've got A to C, A to B, B to C. Had a little slip there. And we have the mirror image here, so we're reflected across the x. Let's just take a minute now and then put triangle A prime, B prime, and C prime. Let's just put the points into a table and see if we can figure out any sort of, not shortcut, but a truth here that we could then leverage to use later on. That A prime is the ordered pair 1, 2, 3, 4, 5, negative 2. B prime, 1, negative 3. And C prime is negative 1, negative 1. All right, now let's look at the ordered pairs that we have for both of our triangles. So the first thing I notice here, my x's, 5, 1, and negative 1, are the same here, 5, 1, and negative 1. All right, no change in the x's. How about a change in the y's here? So I got 2, 3, and 1. A prime, B prime, C prime, negative 2, negative 3, negative 1. We've got something here. So when we look at that, in the cases with which we are reflecting across the x-axis, what do you notice? Nothing changes with our x, but we have the opposite y. So because we're just going across the x-axis, the x stays the same, but we want the opposite y. All right, let's try that in practice. Let's see how we do putting that into practice with the next figure. Now we've got a trapezoid that we're going to reflect across the y-axis. All right, before we do that in the method we did last time with some counting, why don't we try and see if we can use what we used in the last slide here and see if it works. Okay, in the last slide we were going across the x-axis, which meant opposite y. In this time we're going across the y, which is going to mean let's take the opposite x. So I'm going to look at my ordered pairs here and I'm going to rewrite them with an opposite of whatever the x is in this list. So for k prime, I want the opposite of x, which is 2, so that's going to be negative 2, 3. For L prime, I want the opposite of my x, negative 5, 1. For M prime, I'll put my prime symbols there. I want the opposite of 4, which is negative 4, negative 2. And then for N prime, I want the opposite of 1, which is negative 1, and negative 1. All right, now let's graph. I'm going to switch over to a red here so we can see this really clearly. So K prime is at negative 2, 3. 1, 2, 1, 2, 3. Looks like a good start. It's not a good start till I put the prime. So I got to put the prime up there. L prime, negative 5. 1, 2, 3, 4, 5, positive 1. Looking good. M prime, 1, 2, 3, 4, negative. Negative 2. Yeah, good. And N prime, negative 1, negative 1. N prime. Let me get my straight edge. Lock and load here. And put my piece on and draw. Piece on and draw. Piece on and draw. Ooh, that was a bad one. And draw. That looks pretty accurate. So let's just check with the method that we used to do this in the last one. N is 1 away from the y-axis, which is what we're working with. And N prime is also, and they're on the same y. L's are on the same y, L and L prime, same y. 5 away from the axis. M and M prime are on the same y. 4 away. That looks good. K, they're on the same y, where y is 3. K negative 2, or K positive 2, K prime negative 2. That works. So we found another thing here. So now we're seeing if we're going across the y-axis, we want the opposite x for each one of those ordered pairs. Let's put this all together now. So if we're doing reflections now, we're at the 8th grade level now, we don't necessarily have to do the counting. The counting is always going to be there for us. But for us, what we do know is that if we are going to go across one of our major axes, so if we're going across the y-axis, I know what I want to do with my ordered pair. If I'm going across the y-axis, what I want is I want to use the opposite x, and y stays the same. So if I'm reflecting negative 3, 3 across the y-axis, I want the opposite x, 3, and the y stays the same. If I want to go across the x-axis, I want the opposite y, and the x stays the same. So I've got negative 3, 3. Opposite y is negative 3. Negative 3, 1, 2, 3. Negative 3. And here I am at negative 3, negative 3. Okay, so opposite x for going across the y. If we're going across the y-axis, we're going with the opposite x. If we're going across the x-axis, we want the opposite y.